component. So how we have to configure this lookup template component, right? So where you have to give the label, you have to identify the component with the label. So you have to specify the key and you have to specify the record format,
Key,
right? So
key
these are
and
all the
record
things that you have
format,
to.
yes.
Yeah, so with this and within the reformat, you have to write a logic to do the, you have to load the data into the lookup first. After loading the data into the lookup first, you have to write a logic to retrieve the value from the lookup which is loaded in the main memory. Using the lookup underscore load and unloading the data can be done using lookup underscore unload. And also we discussed on the different lookup, dynamic lookup use cases, right? So we discussed on different dynamic lookup use cases. So for the dynamic lookup use cases, we discussed on two different use cases. So today we are going to see on the third use case. So to coming back to this third use case, right? So we will see this third use case. So in the third use case, what we are going to do is we have a trades file. Okay, we have a trades file. We need to identify the differential cost and you have to write it to an output. So for doing this, right? So for doing this, so I think so we can do it. It is not that we have to do it with dynamic lookup. So without going for dynamic lookup, we can do it with the Abinitio component also. So how do we do it with an Abinitio component? So you just tell me how we can do it with Abinitio component. So then I can tell how this can be implemented through dynamic lookup.
Just in the reformat, we can take one global variable.
But why you are saying reformat? So I don't want to do it in reformat.
Scan,
Yeah, that's what my ask. Yeah, that's right. Scan.
scan,
That's correct.
scan. Also, we can do it.
That's correct. That's correct. That's correct. That's correct. Perfect. So we can do it in scan. That's right. So now coming back to this example, right? So we would need the differential cost to be computed like this. Okay, we would need the differential cost to be computed like this. If I have to do it in the dynamic lookup with the help of the functions which are available in the lookup. So how do you do that with the help of the dynamic lookup?
So same input file can be used. The input file can be used as a lookup file.
Okay,
If we'll get that loaded,
okay.
but yeah.
Yeah, design the template. So you have to design the template, right? So what are all the components that you have to use? Tell me the components that you have to use for this use case.
Um, okay.
Okay, so you said,
We
as you said, so
actually
you have to use dynamic, you have to use the lookup template component, right? So you have to use lookup template component, right? For the dynamic
mm,
lookup, you have to use lookup template component. So then you have to read from this file, trades file, right? So input trades file. So after this input trades file, so then you have to do the dynamic lookup within the reformat you have to write the logic. Then you have to write it to an output file. So within the reformat, what is the logic that we should write within the reformat? So within the reformat function template, what is the logic that we have to write?
mm, the same as we use the lookup uh, using the lookup load, we can find the identifier for
Mm,
that.
mm, mm,
Uh,
mm,
if we have a first record,
mm.
then using next in sequence we can have that as a zero. Okay,
Okay,
then okay, for that 100 as we can use a key. So
okay,
we can
okay,
find out the lookup match, and we can use the lookup next function,
okay,
and so we can find the third whatever the what is the value, that 100.20 100.20, right?
Right.
So
Right.
for over there also we can keep the global variable ongoing for the
Okay.
previous record, and for the next record, for the current record we can take it in the local variable, or that uh, we will fetch it from the lookup next in the loop, and we
Okay.
can get that assigned in the we can assign it to the um, what I will say, to the differential cost
Mm, mm,
after
mm,
doing
mm,
the minus
mm,
operation,
mm, mm. Okay.
right?
That's right.
If
Okay.
that is the
Okay.
decimal,
Okay. Fine then. Yeah, that's right. So
92.
you have, yeah, you have the logic. You have got the logic. So now, with respect to the details, right? So details. So what is the lookup? What is the load behavior that you have to use? So lookup underscore identifier. We have different load behaviors, right? So what is the lookup load behavior that you have to use?
uh, look okay, it's means you mean to say the globally or locally?
No, no, no. We have different load behaviors like 0, 1, -1, -2, -3. -1 is appendable lookup file. -2 is updatable lookup
Okay,
file,
okay, okay.
right? So
That is
-2,
updatable, and that is
yeah,
appendable.
appendable or updatable. See, if it is appendable, you have to explicitly
Appendable,
refresh.
updatable. Sorry,
Updatable
updatable.
lookup file. Yeah, ULP, right? So
Yeah.
updatable lookup file.
Uh,
So you have to use minus what is the number? I forget that number. Minus -2, I think so. We will check it out. What is the number? Yeah, it is -3. It is -3. So yes, we can use -3. That's right. So we can use -3. So we can specify the trade lookup file, so which is used for computing this differential cost. So then we're going to have the index file, which is null, and we have to specify the label. So the label is going to be LKP trade, and then we have to give the load behavior, which is -3. Right. So now, so we have a lookup identifier, right? So now we have a lookup identifier. So then next thing is, so I'm just going to create another variable. So which is of a decimal variable. Okay, so which is of a decimal variable. So where I'm going to say v underscore diff underscore cast. Okay, v differential cast is equal to 0. Okay, I'll just keep it as 0. So then what I'm going to do is, so I'm going to do the count and I'm going to store the count value. Okay, so I'm just going to get the count value. Okay, so a decimal of blank. Okay, decimal of blank. So v underscore count, so equal to 0. Okay, so v underscore count is equal to, so v underscore count is equal to, so I'm going to do the lookup underscore count. Okay, lookup underscore count of, so we have to give the lookup identifier. So then you have to do the lookup on LKP trade file to see if there is an existing record, right? So to see if there is an existing record or not. So here, so we can just pass on in dot the trade ID. So based on the trade ID, so I'm going to check whether the trade ID is already there in the lookup or not, right? So based on that, you will
correct.
get the lookup value, correct? Based on
Yeah.
that, you will get the lookup value. So here maybe I can use first define and then default it as 0. Okay, so first define. So because the lookup will return null value, right? So I can just make it as first define comma 0. So where, so I'm going to see, so if v underscore count, v underscore count is equal to 0. So if it is equal to 0, so then this is the first record. We have to add the record, right? So we have to add the record. So if we have to assign a value for the differential cast as well. So we can just give begin and end. So within this begin and end, so we have to write the logic. So the logic that I'm going to write here is v underscore diff underscore cast is equal to 0. Differential cast is 0 because it is the first record. So we have to just add this first record into the lookup file. So we can just say lookup underscore add. So the lookup identifier. So then we can say LKP. You can give LKP trade, right? So LKP trade, so LKP trade, and then you can pass on in dot trade ID, right? So you have to pass the entire record. Okay, okay, you have to pass the entire record. So for passing on this entire record, say for example in the input, so if you want to specify, if you want to send only specific records, so we can give. So where you can give trade underscore ID. So in dot trade underscore ID. So then you have to pass on trade underscore version. So we can give in dot trade underscore version. Okay, in dot trade underscore version, and you can give cast. So then you can give in dot cast. Okay, so I can close this and close this with and then terminate with semicolon. So this will add input data into the lookup file. Okay, this will add the data into the lookup file if the count is equal to 0. If this is the first record, if it is greater than the next thing is, so else if, so if we have a record already there, okay, if you have a record already there, so v underscore count value is greater than 0. Okay, if you have a record already there, okay, if you have a record already there, so we have to retrieve that value, right? So we have to retrieve the value. So when the based on the retrieved value, we have to calculate the differential cost. So we have to say v underscore diff underscore cast. So for this v differential cast, which is equal to, so we have this input cost value, right? So input cost value minus, so whatever the value which is retrieved from the lookup, so we need to put that value. So for retrieved value, right? So we can just do a lookup operation and then we can get the value. So where you can say lookup of, you can say lookup of, so then you can give the lookup identifier, right? So lookup identifier, right? So lookup identifier, then you can give LKP space trade, right? So LKP space trade. So then we can just pass on the in dot trade ID. Okay, so in dot trade ID. So based on this trade ID, right? So based on this trade ID, so we can do a lookup. So and then you can fetch the cost value. Okay, you can fetch the cost value. So after you get this cost value, okay, after you get this cost value, so once you get this cost value, you can subtract it with the in dot cost value, right? So which means you have a record already there. Okay, you have a record already there in the lookup. So you have to get the last record. So we can directly use lookup underscore last, right? So we can use lookup underscore last to get the latest record, right? So you have to always take the latest record, right? So we have to take the latest record. So we can use lookup underscore last to take the latest record, and you can get the cost value and subtract it with the input cost value, assign it to the differential cost. So after this, so we have to add the input data. So once you have done this, you have to add this input data also to the lookup file, right? So because that is can be used for the next day for the next record comparison. So we can just add this to this also. Okay, we can add this to this next also. And so if it is other than any of these cases, so we can just make it as differential cost as 0. So we can just keep it as differential cost as 0. That's it. So and then you can just say out dot differential underscore cost is equal to v underscore differential underscore cost, v underscore diff underscore cost. Then other columns we can just say out dot star colon in dot star, terminate with semicolon. That's it. So is this clear, Suhas? Do you have any questions? Maybe you can go through it again, and if you have any
uh,
questions, we can discuss. Yeah, please.
lookup count is equal to 0. I'm able to recall the lookup ad.
What was it?
Lookup trade. Uh, what does this? I'm audible, na?
Yeah, yeah, you're audible. Yeah, go ahead, please.
What this lookup ad does?
Lookup add will add a record into the lookup file. So this will add the
Lookup
record into
file,
the
right?
lookup file. Yep,
Okay, okay. Then what it is doing? So currently we are considering there is a no record in the lookup file.
correct. First case, no record in the lookup file. If there is a no
That's
record in
why
the
it
lookup
comes
file,
to 0,
mm, mm, mm,
right? So first
mm,
record will go inside. Means
mm,
first record will be in the will go to lookup file.
correct.
Then after the next
Second
record,
record, mm,
second record
mm,
onwards,
mm.
what it does
Your
is like
lookup count.
uh,
Mm,
lookup count is lookup last, but lookup
mm,
last will
mm.
take the it's we have three records, right?
No, no, no. That is what you are not adding the latest record into the lookup file, right? You are adding the latest record after doing the lookup operation. You are adding it. So if you are doing this lookup add first, then it will cause an issue. If you are first adding the record directly into the lookup file, and if you do a lookup last, that will cause an issue. So we are not
Sorry,
adding the record.
come again. Sorry.
So
Come
what
again.
we are doing is
Second condition. So I've clear with first.
okay. So the first record. So you are saying v underscore diff underscore cast value, which is equal to 0. So in we are
Hmm.
adding this data into the lookup file. So when I say add this data into the lookup file, so this is the data which gets added into the lookup file. So where you are having only
Hmm.
the cast, we are just adding only the cast to the lookup file.
Hmm.
So this is my record in the lookup file. So now my input is going to be, so now my input is this one. Now my input is going to be this record version 2.
Hmm.
This is my input, right? So this is my input. So if this is my input, okay, if this is my input, so then so if this is the case, right? So if this is an input, so in the lookup you have one record, right? So in the lookup you have one record, so it is v1, right? So it is v1. So you have v1 in the lookup file. So in the lookup file, you have v1. So now what we are doing is I haven't added this record. I haven't added this record. So what I'm doing is I'm calculating this differential cost. While
Okay.
calculating the differential
Okay.
cost, so I'm just taking the last record. The last record is going to be the original record, the old record, which was added into the lookup file. So from this, so I'm just getting this value and I'm going to subtract it with this incoming value, which is 100.5, and then I'm going to get the result. So this is my input value,
Correct.
and this is going to be my previous value. So after this, I'm adding this input value into the lookup file. So now the lookup file is going to have two records. So the lookup add, I'm doing it after we calculate the differential cost. After I calculate the differential cost, I'm just adding it to this so that this can be utilized for the third record. So in the input, if you get a third record, so then you will have this 100.5 for the third record. So it has to do the comparison with the third record, right? So that will be again, it'll go to the same operation. So since we are adding it, okay, since we are adding it after we do the lookup operation, we can use lookup underscore last. If you first add the
Okay.
value, let's say if you first add the value and if you try to retrieve the value, you have to use lookup underscore nth function. So because it is more like you have to add it in
Hmm.
between and you are going to fetch the record in between, right? So if that is the case, you have to use lookup n. We cannot use lookup first or lookup last. First will give you first record, last will give you the last record. So if I want to
So,
get the intermediate data. So I have to use lookup underscore nth function. So
mm,
is this
okay,
clear?
okay, okay. Okay, what is the difference between lookup last and lookup nth? You said lookup last will just. Yeah,
Okay, so
I'm
lookup
confused.
last.
Hmm.
Lookup. Did you understand this use case? Did you understand this use case?
Understood.
You are clear with this, right? So the lookup nth, why I'm saying this lookup nth is, so say for example, you are first adding there is another logic, okay? That is another way to do. Okay, so first you are going to
Hmm.
add the input record. So you're going to first add the input record.
Correct.
You're going to add the input record to a lookup file using the
Hmm.
lookup file, using the lookup add. Okay, so first you are going to use lookup add and you're going to blindly add this value into the lookup file. Okay, you're going to just say lookup add. After doing this lookup add, so you're going to calculate. So second, you are going to calculate you are going to calculate the differential cost. So for calculating this differential cost, you are doing the lookup operation. So you are just checking whether this value is there in the lookup file or not. So lookup
Yes.
based on trade ID. So
Mm-hmm.
when we are doing this to retrieve the previous cost value, right? So you have the current plus you have the previous record. So you have previous record. So along with the previous record, so you have the current record also there in the lookup. So which one should be used for comparison for identifying the differential cost? You have to use the previous value. Correct. You have to get the
Yes.
previous value. You should not use the current
Previous
value.
one.
So if this is the case, what I'm saying is you have to use the lookup underscore nth function to get this previous record. You should not use first or last. You should use lookup underscore nth function to get the previous cost. That is what I mentioned.
Okay.
So in order to get the previous value, we have to use the lookup underscore n. So where you have to give the lookup identifier. So then you have to give the label. So label is going to be LKP trade, and you have to pass on the count, which record that you want. So from the count, so you have the count value, right? So from the count, so we have this v underscore count. So we can say v underscore count minus v underscore count minus 1. Okay, so y minus 1. So the count will ranges from 1 to 3, 1 to n, right? So the count ranges from 1 to n. So your index ranges from 0 to n minus 1. So count ranges from 0 to n. So your index for a lookup n ranges from, sorry, this one ranges from 1 to n, 1 to n, 1 to n, and this index ranges from 0 to 0 to 0 to count minus 1,
Number
0
of
to count minus 1,
records of
0 to count
count.
minus 1. So that's the reason. So we have used this
Mm,
minus 1. That's the reason we have used this
correct.
minus 1 to get the
Mm,
cast value. So you have
correct.
to use this cast. So this is another way. Okay, this is another approach.
Mm,
So is this clear now?
correct. Clear, clear.
Okay, fine then. Right. So now we will move on to the next topic. So which is indexed compressed flat file lookup. Okay, ICFF lookup file. So for this indexed compressed flat file lookup, right? So we can use this indexed compressed flat file lookup. So there are multiple advantage for this ICFF lookup file. So the advantage is, so we can use this indexed compressed flat file for flat file for so if the data volume is high. Okay, so if the data volume is high, okay, if the data volume is high, so we can compress the data compress the data, store it in hard disk. So while retrieving the data, we can retrieve only the only the required data. Okay, so only the required data by creating index. So index is nothing but a lookup. So the index will have the location where the data file is stored in the hard disk. Where the data file is stored in the hard disk. So the performance is high. So the performance, high performance. So for high performance, so we can go for the indexed compressed lookup file. Okay, so we can go for high performance. So it's performance in terms of performance. So it is high. Okay, so because the retrieval is faster, right? So we can use it for bidirectional read and write operation. Okay, so bidirectional read and write operations. Okay, bidirectional read and write operations. So when I say bidirectional read and write operations, so it is more of, so we can create a lookup file in one component, right? So we can create one lookup file in one component, and then we can read the data from the lookup file in another component. Okay, so we can write in one graph, we can write it in one graph or one phrase and read it from the lookup file in another phase. Okay, so we can do that. So it can be used for bidirectional read and write operations. So for the indexed compressed flat file lookup, so we have a component called write block compressed write block compressed lookup, and you have another component called, for creating the data and index file, you have this write block compressed lookup. For doing a retrieval, so you have write block compressed lookup template. Okay, you have a component called write block compressed lookup template. This write block compressed lookup template component is for retrieving the data from the lookup file. So with respect to this with respect to this with respect to this write block compressed lookup file component, so I will tell about this write block compressed lookup file. So but before that, right, so we will see how this indexed compressed flat file works. Okay, how this indexed flat file works with an example. So we will see that example. Okay, so we will see that example. So let me show you that example. So I can show you the example. Give me a minute. So I think I can start the screen share. Okay. Okay. So here, for this ICFF, right? So we would need the input data to be in the sorted order. Okay. So input data must be in the sorted order. So what we do is we compress the input data and we store the input data in the form of data chunks into the memory location. So and also we'll create a index file. So the index file will have the location. It will have the key value and it will have the location where it is stored in the memory. Okay. It will have the block. So it will be stored in the blocks. So you have 5 blocks, and the 5 blocks will have the record. So and it will have the memory location where it is stored, right? So you'll have this details. Okay, you'll have this details. Create you will compress the input data, store it in the form of blocks into the hard disk, and will create an index file. The index file will have a data like this. So whenever you want to retrieve the data, okay, so whenever you want to retrieve the data, so while doing the data retrieval, okay, so while doing the data retrieval, what we do is, so if you want to retrieve the data, so you will load only the index file into the memory. Okay, you will load only the index file into the memory. So the index file will have the location where the data is stored in the hard disk. Say for example, if I'm going to look for the block C, okay, based on the key value, so the block C, I have to get the data from the block C. So I'll just go to this disk, hard disk, get that block, then load it into the main memory. So from the main memory, so we will do the compression operation, uncompress it. So once you uncompress the data, so you will have the record available in the main memory. So we can retrieve the record from the main memory. Okay, we can retrieve the record from the main memory. So when we say bidirectional read and write, so I said right, we can use the ICFF for bidirectional read and write operation. So if we say bidirectional read and write operation, so whenever you write the data, right? So whenever you write the data, so during the same time, so whatever be the completed records, whatever be the generation. So we call it as generations. So when I say generation, is nothing but, so when you are committing the data, when you are permanently storing the data into the hard disk, it creates a generation. So these are all the completed generation. So you have another graph which makes use of the data from this completed generation, and you have a graph one. Graph one is creating the generation, and graph B is reading the data from the completed generation. So whenever you refresh the lookup, so then the newer generations, once the generations are completed, so it will get reflected in the lookup file, and you can fetch the data from the lookup file. So is this clear? Any questions?
Regarding the refresh of lookup only, how do we refresh that?
How do we refresh? We can use the lookup underscore. There are two things, right? So for refreshing, so what is the load behavior that you have to use? So if you use the load behavior, based on the load behavior, so whenever you do the lookup operation, it will get refreshed automatically. If you are not using the load behavior, then you have to use an explicit lookup call to refresh the lookup. So what is the load behavior that we have to use? So we discussed on the load behaviors, right? Minus
I think
2, minus
minus one, minus one, minus one or
minus
minus
minus see minus 1 will load completed, or load only the completed. It will load all
all
the
the
completed
generation, all
yeah,
the
all the
generation.
generation, right? Minus 1, yes,
Com-
you have to use minus
hmm.
1 completed generation. So if you want to do the update also, which means if you want to insert the record into this lookup file, and also the same record has to be inserted into the lookup file, then you have to use minus 3, right? So you have to use minus 3. So if you want to add records to this ICFF, so you can add records to this ICFF as well at the runtime. So it's more of a dynamic lookup, right? So we can add records to the lookup at the runtime also. So if you are using minus 3, so we can the lookup will get refreshed automatically. Okay, so maybe we can see the load behaviors here. Okay, so we can see the load behaviors. So for the load behaviors, so I can show you the load behaviors. Yeah, so we can see this load behaviors. So we can see minus 1, so which is for loading all the completed generations, right? So minus 1, minus 2, it is ALF. So appendable lookup file. So see this ALF, right? If you are using ALF, so then so you have to call this lookup load function again. Okay, you have to call this lookup underscore load function again. So if it is minus 3 updatable lookup file, so only then it will get refreshed automatically. So for bidirectional read and operation, minus 3 is recommended. Minus 3 is recommended for bidirectional read and write operation. So because there is no need to make a call again, there is no need to make a call again. Okay.
What is bidirectional read and write means?
Bidirectional read and write, at the same time you are going to read it from a lookup, So
Okay.
whenever the lookup file is written in one job, so
Oh, oh,
say your
okay.
lookup is
Got it.
getting created, so you have two graph which is running continuously. Okay, you have two graphs which is running continuously. So
Mm-hmm.
job A is writing
Mm-hmm.
the data to the lookup file. Job B is reading from the
Okay.
lookup file on a continuous basis. So if it is on a continuous basis, so then it is called, then we can refer it as a bi-directional read and write operation.
Okay.
Right. So
And
anything else? Any other questions?
um, and the same way we add the data to the ICFF, or means that write to a block compression profile component I made. But how do we add the data again using the same component? Means, or how do we add it using the lookup load function?
See, we have to see right block compressed lookup component, right? Right block compressed lookup component will create two files, right? So it will create the
Index file. Mm,
data file and index file.
index
So
file.
data file and index file. Say for example, in graph A,
Mhm.
in graph A, so you are you are creating a lookup file. Okay, so creating a lookup file using right block compressed lookup. So you have a graph
Mhm.
B. So where we are doing a lookup based on key value. Right. So we're going to do a lookup based on a key value and add the records to a lookup. So from here also we can add the records when we set the load behavior. When we set the load behavior, we set the load behavior as -3. So if you are setting it as -2 or -3, -2 or -3, both are same. So no, 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 both not, they are different, right? So -2, we have to explicitly load the lookup again in order to refresh that lookup. We have to explicitly make a call to the lookup function. If it is -3, if it is -3, so we have to, there is no need to make a call to the lookup underscore load function. So without making a call, so we can get the value which is added recently. Whatever the value which is added recently, we can be able to get that record. Okay, so that is -3. We have to use the option -3. So graph A is for writing the data. So graph B is for reading the data. So in the graph A, so say for example, so you are so graph A, you have 10 records. Okay, in the graph A, 10 records. So the graph B will make use of 10 records. Okay, the graph B will make use of the 10 records. So in the graph A, okay, in the graph A, you are adding two records. Okay, you are adding two records. So while adding two records, graph B will look only for 10 records. So because 10 records are completed, so only the 10 records will get be visible for this graph B. So in the graph B, during this 10 records, so we can add records to this file. So say if I'm adding three records to this file using the lookup add. So we can add these three records. So and the three records are accessible in the graph B. Okay, three records are accessible in the graph B. So we can be able to access 13 records in the graph B. So since we define it as a write block compressed lookup component, so we can add records into that lookup and the index file will get created for the newly added record. That will be taken care by Abinitio.
So, in the graph B, we are not updating the index file. It will be taken care by Abinitio automatically.
Yeah, exactly, exactly. So because we have defined that particular lookup as a write block compressed lookup, so that is the reason. So it will be taken care by ab initio itself. So since it is a block compressed lookup, and you have used the component, right? So using the component only, you are creating the data file and index file. So the corresponding index will be recalculated by the ab initio itself. Your ab initio component itself will take care of recomputing the index. So data will get added to the data file. The index will get recomputed by the ab initio.
And this
Right.
10 plus 10, uh, these two records you have mentioned, these two records are for?
two records are added in the another job. So two
And
records are added in the other
another,
job. So
okay,
say for
okay.
another job, say for example, so you are running, so say for example you have the first, say for example you are running the job continuously, right? So say for example it
Mm-hmm.
is at 5:15 p.m. Okay, 5:15 p.m. So you have only 10 records. Okay, let's say you have only 10 records. So during this 10 records, you are adding you are adding two records. So at the same time, so 5:15 p.m. So you have only 10 records accessible. Along with this 10 records, so this 10 records from job A, right? So the 10 records from job A. So the three records are added from job B. Okay, three records are added from job B. So totally you have 13 records, but job A is also creating two records. So totally you should have 15 records, right? So at say for example
Okay.
5:30,
Mm-hmm.
let's say 5:30 p.m. So if you are running the job, so the job A and job B will have job A, and graph A and graph B will have 15 records.
Mm. Okay. Yeah. So when in general, these were we are referring it as generations, or
Yeah,
in
that's correct.
normal lookup
Generations.
also. Yeah, in normal lookup also we are considering as a lookup when we add any record to the lookup, because we also having over there as a updatable uh, lookup, right? So
Correct,
that kind of
but correct. But are we creating an index there? So here we are creating an index, right?
okay,
So
okay,
the
okay, okay.
process of creating index along with
Hmm.
the data file is referring it as a generation. So we are completing the generation. So when I say completed generation, it's more of we are committing the data. We are permanently storing the data, and we are making an entry into the index file stating that this new record gets added into the hard disk. So we are making an
Hmm.
entry into the index file as well. So that's the reason we are referring
Hmm.
here it as an index.
Right, right.
Okay, fine. So write block compressed lookup is an Abinitio component, so which is used to used to create data and lookup files for dynamic lookup operation where the input data is compressed and stored in the memory. Compressed and stored in the memory. So location for this component, so we can find it under dataset. Sorry, lookup. We can store it under. We can find it with datasets lookup, datasets and then lookup, datasets and then lookup. We can find this component. So port for this component. So you will have an input port. Okay. So then you will have an output port. Then you will have an index port. Okay. Input port, output port, index port. So then you will have a log port. So parameters for this component. So you will have the key. So you have to specify the column based on which the index has to be created. And also we have to create the block size. We should use the default value. Okay. So we should use the default value. The default value is 10 KB. So we normally use the default value. Will not change this default value. Okay. So it is nothing but so block size to store the data. Okay. This is a block size to store the compressed data. Okay, block size to store the compressed data. We will not make changes to this. So we'll use the default value. Okay, so then block compressed lookup template component is used for the dynamic lookup operations. Okay, for the dynamic lookup operation, for the dynamic uh, lookup retrieval, or I would say it is used to specify the ICFF lookup. Okay, it is used to specify the ICFF lookup for dynamic lookup operations. Okay, so we can get the component from datasets and then lookup folder. We don't have any ports for this component, so ports not applicable. So then with respect to the parameters, so you have column and you have to specify the label. So then you have to specify the key value and you have to specify the record format. So we have to specify these things. Okay, so we have to specify the label, key, and then record format. So the label should have the label, then key should have the key based on which I have to do the lookup. So record format, I have to specify the record format. So is this clear? Any questions? Anybody has any questions?
Did we change the block size
We normally
or
won't change the
usually?
block size. No, no, no. We use the
Okay,
default value. Don't change this. Okay. If you are
okay,
changing it, please write a mail to Abinitio support and then get the confirmation from them, and then you can make the change. So we should not change this block size. So we should use the default value only. If you are planning to change, you have to get a confirmation from Abinitio Corporation.
okay,
So we have to first check with them to see if this can be changed and what is the recommended value that I should use. So based on their confirmation, we have to change. Otherwise, until then, there is no need to make any changes to this block size.
okay.
Okay. So now we will see the use case for this dynamic lookup operation. So what we are going to do is we are going to retrieve the state value from the state lookup, which has city and the state column. Okay. So for this dynamic lookup operation, so we need a sorted data. Okay. We need a sorted data, and your input data should be of fixed size. Okay,
Hmm.
that is also so it's that is another advantage of this ICFF. The another advantage is so data is stored in fixed size. Okay, so data is stored in fixed size so that the memory required for storage will be calculated accurately. So if it is a delimited one, right? You will not specify what is the data that I have to store, right? So, but here it is a data as a fixed size, and if there are any spaces, say for example, if I have 10 characters and if I assign only 5 characters, the remaining 5 characters are compressed. So that's what we are saying. So it's a fixed size and it is compressed. So we are storing it in the compressed format. So your memory usage is efficient. Okay, so your memory usage is efficient. So we need to use an input file component. So I would say uh, input state lookup file. So then so we have
Mhm.
to use a reformat component to convert into fixed width file to convert into a fixed width format. So because your right block compress lookup requires the fixed width data, right? So after that you have to sort the data based on the key value. So the key is going to be city. So based on the key value, you have to sort the data. So after that, so we have to use this right block compressed lookup file. So where you have to create the output file. So which is a data file. So we have to specify the data file location. So and also we have to specify the index file location. Okay, so we have to specify the index file location. The index file location, there is no need to specify. We have to specify only the date. Yeah, we have to specify the index file location also. We have to specify
Hmm.
where you have to specify. You have to write the index file. So then you need to read using an input file component. You have to read a customer file. Okay, so you have to read a customer file. So after reading this, you have to use a reformat. So where you do this dynamic lookup operation. So then you have to write it to an output file. So
So,
it has to be in two phases. Okay, it has to be in two phases. So here you have to be in phase zero. Okay, this operation you have to do it in phase zero. So in this operation, you have to do it in phase one. Okay, so you have to do this in phase one. So phase zero, and this operation you have to do it in phase one. Okay, you have to do it in phase one. So for this phase one, the logic that we have to write here is, so I'll tell the logic that you have to write. So out colon colon reformat of in, reformat of in, reformat of input is equal to begin and end. Within this begin and end, you have to write the logic. Say you have to say out dot state. So, but before that, so we have to create a lookup identifier. So for creating a lookup identifier, so we have to say lookup. Let lookup identifier type. Okay, let lookup underscore identifier underscore type LID is equal to lookup underscore load. We have to specify the lookup file. So dollar AI underscore serial underscore lookup as state underscore lkp dot dat. So that is the one that we give for a data file location. Okay, and for the index file also, I have given this index file location as a serial lookup, and I have given the state underscore lkp dot idx. Okay, so this is a naming convention that I use for the index files. We have to give the label. So the label is going to be lkp state. And then we have to use the load behavior. So we are going to load all the completed generation. So -1 and terminate with semicolon. So here you have to just do a lookup operation. So lookup of lookup identifier. So then we have to say lkp state. So we have to pass input city to retrieve the corresponding state value. Terminate with semicolon. So now for this, right? So we need to use this another component, so which is your write block compressed lookup template component. Also, we should use. Okay, so we have to use the write block compressed lookup template. Also, we have to use write block compressed lookup template component. We should use this lookup template component also. Okay, so that we can do this lookup operation within the reformat. So is this clear? Any questions? Anybody has any questions? So do you have any questions? Any questions?
So I'm sorry, I was speaking on mute. I was just going through. Uh,
Oh, okay.
just one thing like uh, to create the data to create the output data in the or to use the right block complex lookup.
Mm,
The
mm.
its output DML should be in the fixed bit.
Correct. That's correct. Output DML should be in the Excel with. That's right.
Fixed with
That.
DML. Okay.
Yep. It is a
So
mandatory.
before
So
sort.
because we
Okay.
are storing the data in the blocks, right? Data blocks. So we should explicitly tell what is the size of the record, input record. So that's the reason it should be a fixed width.
Okay.
It is mandatory. Okay. If you are giving delimited, it will not accept.
Okay. Yeah. It's clear.
Okay. Okay. Fine. Anything else? Any other questions?
No.
Okay. Okay.